that you say. Of course, data analytics I think that can be used everywhere. But the way the physicists analyze, I can't talk too much because I'm not physicist. But the way they analyze it might be very kind of different because they have really complex process and they want to know many things that they don't use. For example, now Spark, they use usually something that is called Root. It was developed at CERN, and it's a very high performance framework for analysis, for data analysis, that can run on the very high performance, and that's what they are using. But Root, for example, for our context of the analyzing signals and everything, that is not what, it's completely different point of views, we can say. So of course it can be used, probably, but I am not sure if they really, with the tools they have now, if it is enough. So because I am not sure if you were talking about using data analytics, these kind of things, but for the real analysis of the physics. Yeah. Okay. Yeah, I mean, I think that it is, data analytics has been there because they analyze the data. I'm not sure yet about if it is the same point of view and if they are using like predictive analytics, because for example, for the Higgs boson, what they made, that is my understanding of what they made, right? I'm not a physicist. If there is someone here, maybe can get, so they generate a lot of simulations with their data. Yeah. Okay. Yeah. I have to admit that I am not sure how they make all these new creative things, but probably they are more in the theory stuff. Because, for example, the Higgs boson, it's not a new theory. It's something that has been here for 2 years, has been already, yeah.
Excuse me, Antonio, so we are running short
of
time,
sorry.
So we should conclude the session here. Thanks a lot. It was a nice presentation.
Okay,
Thank you very much, Antonio.
So do I take my...
Yes. So meanwhile, we'll just arrange the next presentation.
We have Soumya Gupta, product marketing engineer from Intel. So she is going to handle the next gen big data analytics using Spark. So madam, please.
Good afternoon, folks. I'm originally from Bangalore. It's been 20 years since I left, but I do keep coming often. So this is my hometown, so I'm really thrilled to be here. So I'm Soumya Gupta. I'm a marketing manager in Intel. I'm here to present the next-gen big data analytics using Spark Stack. Before we get started, I do have a little video that I want to show. hopefully you enjoyed the video. It's all about real-time analytics, right? That's the buzzword today. So as you see, there's mountains of data, and something needs to be done with analytics, with all this data. So across the board, you see healthcare, aviation, energy sector, equipment, floor, factory, everywhere. We are looking at more real-time analytics. So before we get started, I want to kind of get a understanding of, how many people have used Spark, are using Spark? 3, 4, very good. How many people are familiar with Spark? Okay. All right, very good. So what I want to cover today is, I want to go over a little bit of, where we are in the big data adoption. Where are we today and where are we headed? And what are some of the real-time challenges? And how did Spark really emerge? What was the reason, for the emergence of Spark? We'll go over some of the most popular analytics technologies, and then we'll, talk about Spark a little more in detail, because that's the session today. I'll cover the, stack, and then I want to cover a real-world use case that we deployed for a customer in China. So we'll talk about that. And then what is our view of the next gen and, big data analytics engine should look like using Spark Stack. And then we are very active in the community. We have done a lot of contributions, and we are actively engaging, and we are working on some development. We're working with partners. I'll talk about that. And then let's talk about how we can collaborate with each other. I don't have a flight to catch, so I'm here today and tomorrow. So, definitely, and there are stalls, I believe, over there, and I'll be, in that area, and I would love to collaborate. Like I said, I'm a marketing person, right? So let's figure out, if you have any applications, let's talk about, how we can collaborate with each other. And then, I'll leave you with some resources. Excuse me for my voice. Pollution, I guess. So where are we in the big data market, right? The market is definitely growing at a very rapid pace. In 2013, IDC estimated the big data technology and services revenue is going to be around 12.95 billion. In 2014, IDC's estimate for the big data technology and services revenue was 16.5 billion. So big data is an aggregation of, infrastructure, software, and services, right? With infrastructure being 7.9 billion, making 48% of the total. And software is 3.96 billion, which is 24%, and services is 28%. Most of this is coming from the Americas region, which is 70% of the revenue, and then 20% is coming from EMEA, and the remaining, is Asia Pacific, which is 10%. So on the right-hand side, you see this is the CAGR growth over the next 5 years. So there's sub-segments underneath each of these infrastructure, software, and services. The way I would read this is, okay, over the next 5 years, servers is expected to grow 26%. That's the CAGR growth. Storage is 28%, and everything else, it's varying from anywhere from 18% to 43%. So definitely, the market is growing. So with any technology, right, there are some challenges. You probably are very familiar with lots of people here in the Hadoop space. You're probably familiar with the big data 4 Vs, right? Which is volume, variety, velocity, and value. So data volume is tremendously growing. 100 terabytes of data is being uploaded into Facebook every day. And by 2020, we are expecting more than 70 zettabytes of data to be produced annually. So addressing this volume is probably the most immediate concern for the conventional IT structures, because it calls for scalable storage and a distributed approach for querying. So something that we need to be looking into it, right? Most of the companies have lots of archived data. In fact, most of the US companies have 100 terabytes of data stored. But they don't have a way to process the data, because the volume is much larger than what a conventional database can handle it. So the next V is variety. The data source is diverse. It can come from all kinds of sources, right? It's inconsistent formats, different formats, inconsistent schemas. because data is coming from text from social networks, pictures, images, video files, lots of different places, and raw feeds from sensors. So these are some of the sources. You have transactions, scientific industrial equipment, internet search, everywhere, right? And sensors are spitting out a lot of data. With all the IoT boom, all the sensors are picking up lots of raw data. It could be video files, any kind of data, and they're feeding it off to gateways and to the cloud to process. So there is a lot of unstructured data which can comprise more than 60% of the internet data. And billions of data is being uploaded into Facebook and Twitter. So getting all this data and making some sense out of it, and that's when you can do some analytics, right? So the third way is the velocity. It's growing definitely at a pace as volume. It's just definitely growing in a bigger pace. There's an increasing speed at which the data is being created and at which the data is being produced and stored and analyzed. So with the mobile era and the internet era, there's so much services are being consumed, and at the same time, the data flow is flowing back into the provider. So there's a lot of data, and most of the companies are exploring real-time. They're interested in more real-time data. So in fact, this study shows that more than 50% of the businesses are looking for some real-time data. Because, for example, online retailers, right? They want to follow through a customer for every click, what you're doing, where you're headed, how you're doing, and so they can have a competitive edge and throw some personalized ads or anything towards them. So the next thing is value, right? We know big data is huge, but we need to derive value out of this. That's the key thing. So data, we saw that data is massive, expanding, messy, noisy, in all different formats, right? So this is worthless. This data is worthless if you don't make if there's no visualization or analysis being done. So definitely real-time analytics is the key to derive value out of big data. Now let's take a look at some of the, how real-time analytics is, the key to unlock the potential of big data, right? So there's a study from GigaOM, where they talk about petabyte scale data streaming at blinding speeds of sensors, and streaming data needs to be cleansed and secured on the fly. So the whole premise of this is to analyze the streaming data and query it and process it in real time. So businesses are definitely looking into the real time analytics, right? Like many of you, we also heard in the panel discussion. So another study from Evans shows that developers are looking at analytics tasks that could be rendered in minutes as opposed to days. And there was a poll done where 38.6% of the developers had already installed Apache Spark because they want to get something that's much faster than MapReduce. So clearly, real-time analytics is pretty vital for most businesses. So the McKinsey report, right? We're talking about real-time retail store analytics. They're looking at, they made a study and they're looking at organizations could increase their operating margins by more than 60%. And they also estimate that US healthcare sector could reduce costs by 8% by doing just data analytics because they can improve on the efficiency and quality and all that stuff. So now let's take a look at this graph here, right? So this is, this shows the retail store analytics. So this is used to improve the operations and revenue of a store. So you can understand the customer behavior. Business owners are interested to understand the customer behavior, patterns, study the patterns, the traffic patterns, and they can do some staff optimizations, layout optimizations, and increase their operational efficiency. And they can also detect if there's any fraudulent activities, they can have some video surveillance cameras, all kinds of things, right? They can improve, lots of different, efficiencies, and they can do a lot of different things. So the study really shows, they could also see how many people are, coming into the building or, their retail store, how many exits per day, what is the minimum shopper's time, what is the maximum shopper's time, what are some of the peak shopping hours so they can have the staff in store, or what are the peak staffing layouts, right? I mean, routes that they're taking. So they could do some layout optimization. So they're interested in collecting lots of data. So the American Apparel, right? This is a store. So they did work on real-time store analytics, and they were able to get 30% boost in their sales and 20% reduction in theft. Because, like I said, they could have the video surveillance cameras and they could, detect any kind of activities that are going on. So real-time analytics is the next frontier to unlock the potential of big data. And for businesses to do analytics, we need to have a robust framework that will support the real-time analytics, right? We need to have good streaming, and we'll talk about this later. So now let's take a look at some of the most popular analytics technologies: Storm, Dremel, Impala from Cloudera, and Spark, right? So Storm, I think there was a session before. I didn't get a chance to attend. So Storm is a distributed real-time computation framework for distributed real-time processing for streaming. It's very fast. It can be worked with most of the programming languages, and it's written primarily in Clojure, Java, Python. It's scalable architecture. It's fault-tolerant. Integrates very well with queuing and database technologies. So it used to be an incubator project last year, and then it became a top Apache level project. So Dremel is an interactive query system. It can run, trillions of rows in seconds. So because it uses some nested data models. Whereas the same thing, if you want to do in MapReduce, you can, take a series of, tasks. But then they complement with each other. So it's a proprietary solution from Google. It has thousands of users in Google using it, and it's also scalable to thousands of nodes, CPUs with petabytes of data in them. So it's really fast. And it has like a SQL-like language to express ad hoc queries, you could pretty much use Dremel. You could pretty much use MapReduce to develop your data set, and then with billions of records, and then use Dremel to start querying. So they complement with each other. So the next thing is Impala, right? Impala is a open source SQL query engine, runs on Hadoop. It does enable very low latency queries stored in HBase, HDFS, for different formats, right? So now let's talk about Spark. Spark used to be a small research project in UC Berkeley. So these researchers, it's around about 2009 is when they started in AmpLab. So these researchers were using MapReduce, and they felt that MapReduce was not very efficient in doing iterative computing and interactive computing. So that's why they, started writing Spark. They introduced Spark, and what they did was they wrote the base, core layer, and they used it for traffic monitoring and, predicting the traffic congestion in San Francisco. So after that, they brought it back to the lab, and they started adding other components on top of it. And then they open sourced it under a BSD license in 2011. And later it was donated to Apache Software Foundation, and then it was in an incubator.